November 23, 1944. The Baltic Sea churned grey and menacing as Obergefreiter Hans Müller, barely 18 years old, stood nervously beside the massive coastal defence gun overlooking the Danish straits. The concrete bunker felt like a tomb, its walls 3 meters thick and designed to withstand the heaviest bombardment the Allied forces could deliver. Snow had begun to fall in thick, wet flakes, dusting the gun barrel that stretched nearly 15 meters into the bitter morning air, like the finger of some mechanical giant. Hans had been assigned to this position just 48 hours earlier, fresh from the artillery training facility at Doberitz, with hands that had never loaded a real shell into a weapon this enormous, this terrifyingly powerful. He believed this would be just another routine drill, another chance to prove himself worthy of defending the homeland against the increasing Allied naval presence in these waters. He had no idea he was about to accidentally create one of the most devastating artillery pieces in military history. A discovery that would echo through the technical corridors of both German and Allied military establishments for decades to come. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you are watching from. It really helps support the channel. What Hans would discover in the next few minutes would transform not only his understanding of warfare, but also provide Allied intelligence with crucial information that would change the course of coastal bombardments for the remainder of the conflict, influence post-war artillery development, and create tactical doctrines that would persist long into the Cold War era. Hans Müller had grown up in the small Bavarian village of Oberammergau, where his father operated a woodworking shop that specialized in creating intricate religious carvings for local churches. The precision required for that delicate work had given Hans an appreciation for mechanical details and careful craftsmanship that would prove both blessing and curse in his military career. His mother had packed his kit with hand-knitted socks and a small wooden cross carved by his father, reminders of a peaceful world that seemed increasingly distant from the concrete and steel reality of coastal fortifications. The journey to Battery Lindemann had taken 3 days by military transport, passing through increasingly devastated landscapes as they moved closer to the front lines. Hans had seen his first destroyed city in Hamburg, where Allied bombing had left entire neighborhoods reduced to skeletal frameworks of burned buildings. The sight had filled him with a mixture of anger and determination that sustained him through the grueling final weeks of artillery training. At the training facility, Hans had worked with smaller coastal defense weapons, learning the mathematics of trajectory calculation, the chemistry of propellants, and the engineering principles that governed long-range accuracy. His instructors had noted his exceptional mechanical aptitude and recommended him for assignment to one of the largest gun positions along the Atlantic Wall fortifications. Battery Lindemann represented the pinnacle of German coastal defense engineering. The position had been carved from solid rock over a period of 18 months, using both military engineers and conscripted labor from across occupied Europe. The main gun emplacement sat 60 meters above sea level, providing commanding views of the shipping lanes that connected the Baltic Sea to the North Sea. The concrete structure extended deep underground, with ammunition storage, crew quarters, power generation facilities, and command centers, all connected by a network of tunnels designed to survive direct hits from the largest naval guns. The weapon itself was a marvel of industrial engineering that few soldiers ever had the opportunity to operate. The barrel alone weighed over 80 tons and had been manufactured at the Krupp Works in Essen, using steel alloys developed specifically for long-range artillery applications. The rifling inside the barrel followed a precise mathematical spiral calculated to impart optimal spin stabilization to shells weighing more than 1,000 kilograms. The breech mechanism operated with tolerances measured in fractions of millimeters, and the hydraulic loading system generated pressures sufficient to lift a small automobile. Hans had memorized every technical specification during his training, but seeing the weapon in person still overwhelmed him with its sheer mechanical presence. The gun dominated the bunker space like a sleeping giant, its polished steel surfaces reflecting the harsh electric lighting with an almost mirror-like finish. Control panels lined the walls, filled with gauges, switches, and indicators that monitored everything from barrel temperature to hydraulic pressure to electrical system status. The morning had started at 5:30, with the sound of Feldwebel Kruger's leather boots echoing down the concrete corridors as he made his rounds, checking on each crew position and ensuring that all men were properly dressed and equipped for the day's training exercises. Kruger was a veteran of both the Polish and French campaigns, a career soldier who had requested transfer to coastal defense duty after being wounded during the advance toward Moscow. He walked with a slight limp from shrapnel that had nearly cost him his left leg, but his 20 years of military experience made him invaluable for training young recruits in the complexities of operating heavy artillery. Hans had quickly learned to respect Kruger's expertise, even though the Feldwebel's methods could be intimidating. The older soldier had a way of explaining technical procedures that made complex mechanical systems understandable, breaking down each step into logical sequences that even nervous recruits could master with sufficient practice. But he also insisted on absolute precision in following safety protocols, having seen too many training accidents caused by small deviations from established procedures. The bunker complex housed not just the main gun position, but also quarters for 12 men, storage for 60 rounds of ammunition, emergency medical facilities, communications equipment connected to coastal defense headquarters, and enough supplies to sustain operations for up to 2 weeks without external resupply. The Germans had learned from their experiences during the early years of the conflict that isolated positions needed to be completely self-sufficient to remain effective under siege conditions. Hans rubbed his eyes and pulled on his thick wool uniform, still adjusting to the perpetual dampness that characterized underground military positions. The heating system struggled against the combination of concrete thermal mass and Baltic winter temperatures, creating an environment that felt perpetually cold despite the mechanical warmth generated by electrical equipment and human occupation. The constant smell of gun oil, concrete dust, and industrial lubricants had become as familiar as breathing during his short time at the position. He made his way through the connecting tunnel to the mess area, where the morning meal consisted of black bread, ersatz coffee made from roasted grains, and a thin soup containing small pieces of preserved meat. The food reminded him painfully of his mother's cooking, not because of any similarity in quality, but because of the complete absence of the care and attention that had characterized every meal of his childhood. Military rations served their nutritional purpose, but provided no comfort for soldiers far from home. After breakfast, Hans reported to the main gun position, where Obergefreiter Klaus Zimmermann was already conducting pre-operation checks on the weapon systems. Zimmermann represented everything Hans hoped to become as an artillery operator. At 26 years old, he had 3 years of experience with coastal defense weapons and had participated in several live-fire exercises against Allied naval reconnaissance units. His technical knowledge seemed encyclopedic, and his calm demeanor under pressure had earned the respect of both subordinates and superiors. Zimmermann came from Berlin, where his father had worked as a precision machinist in one of the city's many industrial facilities. This background had given him an intuitive understanding of mechanical systems that complemented his formal military training in artillery operations. He could diagnose problems with hydraulic systems by listening to the sound of the pumps, detect ammunition handling issues by observing the movement of loading mechanisms, and calculate firing solutions in his head with accuracy that rivaled the mechanical computing devices used by more advanced artillery positions. "Good morning, Möller," Zimmermann said as Hans approached the gun position. "Today we will focus on loading procedures for high-explosive shells. The work requires concentration and precision, but once you master the basic sequence, it becomes as natural as breathing." The two men stood before the massive breech mechanism, which dominated the rear portion of the gun like the door to a bank vault designed by engineers who understood that failure meant death. The mechanism weighed nearly 3 tons by itself and incorporated safety interlocks designed to prevent accidental firing during loading operations. Every surface showed the careful attention to detail that characterized German precision engineering, with tolerances measured in fractions of millimeters and finishes that would have been appropriate for civilian machinery of the highest quality. "Listen carefully, Möller," Zimmermann said, his breath visible in the cold air as he began the formal instruction sequence. "This weapon fires high explosive shells that weigh exactly 1,030 kilograms each, The propellant charge weighs another 330 kilograms and contains enough explosive force to propel our shell over distances exceeding 50 kilometers. When you load the shell, you must ensure the nose cap is properly seated. The driving band aligns perfectly with the barrel rifling, and the electrical connections for the fuse system are secure. Hans nodded eagerly, though his stomach churned with a mixture of nervousness and excitement that reminded him of his first day at the village school. He had practiced loading procedures on smaller guns during training, but nothing had prepared him for the sheer scale of this weapon system. The shells stood nearly as tall as he did, their polished steel surfaces reflecting the bunker lighting like mirrors, and moving them required a complex system of hydraulic rams and mechanical hoists that operated with the precision of Swiss clockwork. The loading system itself represented years of engineering development by teams of specialists who had studied every aspect of efficient ammunition handling. Hydraulic pumps generated pressures sufficient to lift the massive shells with smooth, controlled movements, while mechanical guides ensured perfect alignment with the gun's chamber. Safety interlocks prevented operation if any component was not properly positioned, and redundant systems protected against the catastrophic failures that had plagued earlier artillery designs. The first shell of the morning exercise was already positioned on the loading tray, its presence dominating the rear section of the bunker, like a sleeping giant waiting to be awakened. The shell gleamed dully in the harsh electric light, its copper driving band polished to a mirror finish that reflected the surrounding concrete walls with distorted clarity. Hans could see his own reflection in the metal surface, young and nervous, and somehow smaller than he had imagined himself to be. The shell bore official markings, indicating it was a high-explosive round, designed specifically for long-range bombardment of naval targets, with ballistic characteristics optimized for penetrating ship armor and creating maximum internal damage. The nose fuse could be set for either contact detonation or time delay explosion, depending on the tactical requirements of the specific target. German engineers had spent years perfecting the explosive composition to maximize destructive force while maintaining stability during the tremendous acceleration forces generated by firing. The morning had started like any other at Battery Lindemann, one of the most formidable coastal fortifications along the Atlantic Wall. Hans had awakened at 5:30 in the morning, to the sound of Feldwebel Kruger shouting orders down the concrete corridors. The bunker complex housed a single 406mm gun, one of the largest artillery pieces ever constructed for coastal defense. The weapon weighed over 160 tons and could theoretically fire shells weighing more than 1,000 kilograms over distances exceeding 50 kilometers. Hans rubbed his eyes and pulled on his thick wool uniform. The dampness in the bunker made everything feel perpetually cold, and the constant smell of gun oil and concrete dust had become as familiar as breathing. He had dreamed of operating massive weapons like this since joining the army 6 months ago, but now that he was here, the reality felt overwhelming. "Müller," Feldwebel Kruger called out as Hans made his way to the gun position. "Today, you will learn the proper loading sequence. Obergefreiter Zimmermann will supervise you." Zimmermann was a veteran artilleryman, 26 years old with 3 years of experience operating coastal guns. He had kind eyes, but spoke with the precision of someone who understood that mistakes with weapons this size could be catastrophic. The two men stood before the massive breech mechanism, which opened like the door to a bank vault. "Listen carefully, Müller," Zimmermann said, his breath visible in the cold air. "This weapon fires high explosive shells that weigh 1,030 kilograms each. The propellant charge weighs another 330 kilograms. When you load the shell, you must ensure the nose cap is properly seated and the driving band aligns perfectly with the rifling." Hans nodded eagerly, though his stomach churned with nervousness. He had practiced loading procedures on smaller guns during training, but nothing had prepared him for the sheer scale of this weapon. The shells stood nearly as tall as he did, and moving them required a complex system of hydraulic rams and mechanical hoists. The first shell of the morning exercise was already positioned on the loading tray. It gleamed dully in the harsh electric light, its copper driving band polished to a mirror finish. Hans could see his reflection in the metal surface, distorted and young-looking. The shell bore markings indicating it was a high-explosive round designed for long-range bombardment of naval targets. "Now watch carefully," Zimmermann said, beginning to demonstrate the loading sequence. "First, you verify the shell type and condition. Check for any cracks in the casing, damage to the driving band, or problems with the nose fuse. Then you align the shell with the chamber using the mechanical guide." As Zimmermann spoke, Hans noticed something unusual about this particular shell. Unlike the training rounds he had seen before, this one had additional markings near the base. Small numbers and letters were etched into the metal, barely visible unless you knew to look for them. He assumed these were standard manufacturing codes and said nothing. The loading procedure began normally. The hydraulic system lifted the massive shell and began pushing it into the gun's chamber. Hans watched intently, trying to memorize every step of the process. The shell moved slowly but steadily, guided by precise mechanical tolerances that had taken German engineers years to perfect. Then Zimmermann stepped back and gestured for Hans to take control. "Your turn, Möller. Remember everything I showed you. Take your time and double-check each step." Hans felt his heart racing as he moved to the control position. The hydraulic controls were heavy and required significant force to operate. He began the sequence exactly as he had been taught, but his inexperience showed in the hesitant way he operated the machinery. As the shell neared the final loading position, Hans noticed the mechanism seemed to be binding slightly. The shell was not seating as smoothly as it had during Zimmermann's demonstration. Unsure of what to do, he applied additional pressure to the hydraulic control. That was his first mistake. The increased pressure caused the shell to slam into the chamber with much greater force than intended. The impact compressed the propellant charge and triggered something that should never have happened. The shell's experimental time delay fuse, designed for testing purposes and never meant for live firing, activated prematurely. But instead of detonating immediately, the modified fuse began cycling rapidly, creating a feedback loop with the gun's electrical firing system. Hans heard a strange clicking sound coming from within the weapon, like a mechanical heartbeat that was gradually accelerating. "That does not sound right," Zimmermann said, moving quickly to the control panel. "Stop the loading sequence immediately." But when Hans tried to reverse the hydraulic system, nothing happened. The shell was locked in position and the clicking sound was growing faster. Neither man had ever heard anything like it during their training. Within seconds, the clicking became a continuous buzz, and then something extraordinary occurred. The gun's firing mechanism began cycling automatically, drawing power from the bunker's electrical system and triggering the propellant charges in rapid succession. The first shot fired with a tremendous roar that shook dust from the concrete ceiling. Before Hans or Zimmermann could react, the gun fired again, and again. The massive weapon had transformed into something resembling a machine gun, albeit one that fired 1,000-kilogram shells at intervals of roughly 3 seconds. The sound was unlike anything either man had ever experienced. Each shot produced a concussion that felt like being punched in the chest by an invisible giant. The concrete bunker, designed to withstand bombardment, began to vibrate sympathetically with the rapid firing. Equipment rattled on shelves, and the air filled with concrete dust and gun smoke. Hans stood frozen in terror, his hands still on the controls that no longer responded to his commands. The weapon continued firing automatically, hurling massive shells toward the Baltic Sea at a rate that defied everything he had learned about artillery operation. Zimmermann ran to the emergency telephone to contact the battery commander, shouting to be heard over the continuous thundering of the gun. "Herr Hauptmann, we have a situation at gun position 1. The weapon is firing automatically, and we cannot stop it." The response from the command post was immediate confusion, then alarm. "Repeat that, Zimmermann. Did you say the gun is firing by itself?" "Jawohl, Herr Hauptmann. It has fired approximately 20 rounds in the last minute, and shows no signs of stopping." Outside the bunker, the scene was equally chaotic. Other members of the battery crew had taken cover, assuming they were under attack. The massive shells were landing in the Baltic Sea roughly 50 kilometers away, creating enormous waterspouts that could be seen from the Danish coast. Each impact sent tons of seawater skyward and created shockwaves that could be felt through the sea floor. Back inside the bunker, Hans finally found his voice. "Herr Obergefreiter, what do we do? How do we stop it? Zimmermann was studying the electrical panel with growing concern. I have never seen anything like this. The firing circuit appears to be stuck in a continuous loop. The only way to stop it might be to cut the main power supply. But even that presented problems. The gun's electrical system was connected to the bunker's primary power grid, which also supplied lighting, ventilation, and communications equipment. Cutting power would leave them in darkness in a sealed concrete structure. As they debated their options, the gun continued its relentless firing. Hans counted 47 shots in the first 5 minutes, a rate of fire that should have been impossible for a weapon of this size. The heat generated by the continuous firing was beginning to warm the entire bunker, despite the frigid November weather outside. Then Hauptmann Weber arrived, having run from the command bunker through connecting tunnels. He was a career officer with 15 years of artillery experience, and his face showed a mixture of amazement and concern as he assessed the situation. "How long has this been going on?" he demanded. 7 minutes now, Herr Hauptmann," Zimmermann replied. "We estimate 63 rounds fired so far." Weber moved to the observation periscope and peered out toward the sea. The water was churned into white foam from the continuous impacts, and he could see Danish fishing vessels in the distance, hastily changing course to avoid the impact zone. "This is remarkable," he said, almost to himself. "The weapon is firing faster than our best machine guns, but with shells that weigh more than a motorcycle. The tactical implications are extraordinary." Hans felt a surge of pride despite the chaos. His accidental discovery might actually be militarily significant. But his optimism faded when Weber turned back to face them with a grim expression. "However," the Hauptmann continued, "we are depleting our entire ammunition supply. At this rate we will exhaust our shells within 20 minutes, and if the gun barrel overheats, it could rupture and destroy this entire position." The reality of their situation began to sink in. They had accidentally created a super weapon, but one they could not control, and that might destroy itself through its own rapid firing. Zimmermann had been studying the technical manuals while they spoke. "Herr Hauptmann, I believe the problem originated with this shell." He pointed to the markings Hans had noticed earlier. "These codes indicate it was an experimental round with a modified fuse system. It was never supposed to be included in our regular ammunition supply." Weber examined the markings through a magnifying glass. "These are test specifications from the artillery development facility at Kummersdorf. This shell was designed for time delay experiments, not combat use." The situation was becoming clearer but no less dangerous. Hans had accidentally loaded an experimental shell that had created a feedback loop with the gun's firing system, turning it into an automatic weapon. The question now was how to stop it before it destroyed itself or exhausted their ammunition reserves. "We need to interrupt the electrical circuit," Weber decided, "but we must do it carefully to avoid damaging the gun permanently." Working together, the three men began tracing the electrical connections by flashlight, preparing to selectively disable power to the firing mechanism while maintaining other essential systems. The gun continued its thunderous firing throughout their work, each shot reminding them of the urgency of their situation. After 15 minutes of careful electrical work, Zimmermann found the correct circuit breaker. "I believe this controls only the firing system," he announced, "but once I switch it off, we may not be able to restart the gun at all." Weber nodded grimly. "Do it. Better to have a disabled gun than no gun at all." Zimmermann threw the switch, and suddenly the bunker fell silent. After nearly 20 minutes of continuous thundering, the absence of sound felt almost supernatural. Hans realized his ears were ringing so loudly he could barely hear his own thoughts. They had fired 147 rounds in total, more than this position would normally fire in 6 months of regular operations. The barrel was glowing red-hot despite the cold weather, and steam rose from the metal as snow touched the heated surface. But the immediate crisis was over. Hans slumped against the concrete wall, exhausted by the adrenaline and noise. He had gone from nervous recruit to accidental military innovator in the span of 20 minutes. Weber was already on the telephone with higher command, reporting the incident and requesting technical specialists to examine both the gun and the experimental shell. "Yes, Herr Oberst, you heard correctly. 147 rounds in 20 minutes. We need ammunition resupply and technical analysis immediately. As the day progressed, word of the incident spread throughout the coastal defense network. Engineers and artillery specialists arrived from across the region to study what had happened. Hans found himself retelling his story dozens of times, each listener more amazed than the last. The experimental shell, they learned, had been included in their ammunition supply by mistake. It contained a prototype fuse designed to test rapid-fire capabilities for future artillery development. When combined with the specific electrical characteristics of their particular gun, it had created an accidental automatic firing system. Within days, teams of engineers were working to replicate the effect deliberately. If they could control and harness Hans's accidental discovery, it might provide a significant advantage in coastal defense. The concept of rapid-firing heavy artillery could revolutionize naval bombardment tactics. But Hans also learned something that would haunt him for years afterward. Intelligence reports revealed that several Danish fishing vessels had been caught in the impact zone during the incident. While no direct hits occurred, the shock waves and water displacement had capsized 2 boats, and 7 fishermen had lost their lives in the frigid Baltic waters. His moment of military innovation had come at a terrible human cost. The young recruit who had been eager to prove himself worthy found himself grappling with the reality that his actions, however unintentional, had contributed to civilian casualties. The technical analysis of the incident continued for weeks. Engineers determined that the accidental rapid-firing capability could theoretically be reproduced, but only under very specific conditions. The experimental fuse, the particular electrical characteristics of that specific gun, and even the ambient temperature and humidity had all played roles in creating the phenomenon. More importantly, they discovered that sustained rapid firing caused severe barrel wear and dramatically reduced the weapon's accuracy. After just 20 minutes of automatic operation, the gun's effective range had decreased by nearly 30%, and its precision was compromised for long-range targets. The tactical advantage of rapid fire was offset by the loss of the accuracy and range that made coastal defense guns effective in the first place. Military planners concluded that while the discovery was scientifically interesting, it was not practically useful for combat operations. Hans was eventually transferred to a different position, partly to continue his artillery training, and partly because he had become something of a celebrity within the coastal defense forces. Officers would visit just to meet the young recruit who had accidentally turned a massive gun into a machine cannon. He never forgot the weight of responsibility that came with operating such powerful weapons. The memory of those Danish fishermen stayed with him long after the technical fascination of his discovery had faded. In quiet moments, he wondered if his eagerness to prove himself had made him careless with procedures that existed for very good reasons. The gun at Battery Lindemann was eventually repaired and returned to normal operation, but the incident had revealed important lessons about experimental ammunition and electrical firing systems. New procedures were implemented to prevent similar accidents, and experimental shells were more carefully segregated from regular ammunition supplies. Years later, after the conflict had ended and Hans had returned to civilian life, he learned that Allied intelligence had obtained detailed reports about his accidental discovery. The information had helped Allied naval planners understand German coastal defense capabilities and plan accordingly for amphibious operations. His moment of innovation had inadvertently provided valuable intelligence to the enemy, though this was not something he could have foreseen at the time. The fog of conflict meant that even accidents could have strategic implications that extended far beyond their immediate consequences. The story of the 18-year-old who accidentally created a machine cannon became part of military folklore, told and retold in artillery training programs, as an example of how small mistakes could have enormous consequences. It served as a reminder that powerful weapons required not just courage and dedication, but also precise adherence to safety procedures developed through hard-won experience. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Do not forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.